Hello, everyone. Welcome to today's lesson. And in today's lesson, we have a simple task of looking at the solution to the assignment that was given in the previous lesson. Okay, so just as you can see on your screens, we have vectors. So lesson 3 assignment sort of. All right, so quickly, let's see. We know that anytime we read questions, we have to make it a habit of underlining the salient part. So let's read, underline the salient parts, if any. Okay, so a vehicle which has broken down is pushed by 3 men with forces. Okay, so with the forces that we have here, calculate the magnitude correct to the nearest Newton. So you underline this. Very critical. There is a required approximation that you are supposed to take your answer, okay, for the magnitude. And the direction correct to the nearest degree. So you underline this as well. There is a required approximation for the direction that you are asked to find of the resultant of the 3 forces. Okay, so as usual, you can see that the forces that we have here didn't come with names. Usually, we want the forces to be named. So on that note, you start by writing solution, then you come and write let. So you give your forces names. You can choose to write given, then extract the forces without their names, then later come and write let. But it will not be necessary. Just write let straight away. Okay, so you can see that the forces are given names. Our usual F sub 1, F sub 2, F sub 3 for the 3 forces that we have here respectively. Okay, but we know the resultant R will be equal to the sum of the 3 forces. So you can see the marks there. When you're able to write, I'll come to the penalty. So if you didn't write let, then you wrote F1 or you wrote given F1, this is equal to, it will be B half. You won't get the B1, take note. Okay, then we know the resultant R will be equal to the sum of the 3 forces. Okay, now we know that the forces, unfortunately, are not in the column or the Cartesian form that we can easily add. Okay, so they came in the magnitude bearing form. And we said magnitude bearing form vectors are not that friendly. So usually if you want to work with them in terms of addition, what have you, algebra, you have to convert them to their corresponding column. So if you take the first force F sub 1, if you want to take it to the column, okay, the magnitude bearing to column, okay, form, we are going to get the magnitude, okay, which is 220, then sine of the bearing angle, which is what, 30 degrees. Then 220 cos the bearing angle, okay, 30 degrees. And please don't forget the degrees. This time around, I will be lenient. I think I stated it in our previous lesson. Okay, so if you forget the degrees next time, you will be penalized. When you are feeding your calculator, because your calculator, should I say, the programming, you see that on top there you see D. It means what you have there is already in degree. So anything, any value that you are dealing with, if you are dealing with an angle, it will be treated as an angle in degrees. If it's in radians, then it should be, you can see that you have this. Let me quickly draw your attention to that. Your calculator, you see this D, okay, in a box somewhere. It means your measurement in terms of angles, any calculation will be in degrees. We have also R, which will be radians, and all of you do relative math. So you know that when you did trig, you did radians. Okay, and there is another one which is J. Okay, usually further studies, you know, that is grad. Okay, so these two are the ones that you need to know at your level. So if you are doing any calculation and it's in radian, you have to change your the settings to the radian settings before you start dealing with it. Okay, but that was just by the way. So now let me go back to what I'm doing. So in that case, when you are writing it, you will bring the degrees. Take note, but when you're feeding your calculator, you wouldn't, okay, feed your calculator with degree. So you only write sine 30. Feed your calculator with that. But here you have to attach the degree. So correspondingly, this will be 240 sine 120, 240 cos 120. Then this one will also be 315 sine 90, 315 cos 90 degrees. So don't forget the degrees like I stated earlier. You use your calculator to do this. So that will give us what we have here for the F1 in column form, F2 in column form, F3 in column form. Take note. So at this point, you know you are adding these three, okay, forces in column form. So you add corresponding components, which will give us the S component to be what we have here approximately 4dp. Then the Y component will give us what we have here 4dp. So you can see that I approximated, therefore I have indicated my approximation. Now that I know my sum of the vectors, sorry, the forces in the column form, I should be able to find the magnitude easily. So I come and write, therefore, the magnitude of R will be equal to, I can't use R to conclude because I introduce R. Okay, then root of, you know, it will be your S component squared plus Y component squared. So use your calculator to do this, use your calculator to give you this. Then after that, you can choose not to sum. Just use your calculator to do the whole of this. Okay, so that step you can miss it, you won't lose any marks. But I've told you when you are squaring, get the squares for each of them before you can get to your final answer. You take the square roots. Okay, the sum is not, so that will give you this answer. But you know, you were asked to find the magnitude of the resultant. Your resultant was not given a name. You decided to give it a name for, what do you call it? An ideal presentation for less work to be done. So it has served its purpose. You draw your conclusion with the resultant. So resultant in the absolute value sign, meaning the magnitude of the result. Someone can write it in full. Magnitude of the resultant will be equal to. And you can see that the question asks you to take it to the nearest what? Whole number or the nearest newtons. So this one to the nearest newton will give us 6.3 what? 7, and that's what you have your newtons. And I indicated my approximation, nearest newtons. Okay, that will be it for the magnitude. Now we are going to the direction, which is the same as the bearing. Okay, so for you to get the bearing, I've told you, you cannot avoid, okay, this diagram. You need to draw. So when you draw your X and Y, okay, the Cartesian plane, and you indicate your true north on the positive Y axis, you know, bearing here, the vector here, or the force here in column form will be, the S component is this. So you move this unit on the positive X axis, and the Y component is also positive, so you move up, then you state the values, okay, there. Okay, then this angle here will be theta, so it means what you have here, let me pick so that you can easily see. Okay, so it means what you have here will be your vector R, your resultant. Okay, because this is the S component of the resultant, Y component of the resultant. So this then becomes your resultant. So you indicate your arrow. Somebody can do this, indicate the arrow here, come and indicate the arrow here too. But this one that is very important, okay, at this point. So this diagram too, when you draw B2, is very critical. But before you can find theta, you have to know the opposite adjacent, so we can use the trig ratio. So it means tan theta. But here we know the bearing angle will be this angle from the true north up to this line. And we know that this angle here plus this angle should give you 90. So if you want to get this angle, you subtract theta from 90. So that will give us the bearing. So, but tan theta, if I'm able to find theta, I'm good to go. Tan theta will be equal to opposite, which is this, over the adjacent, and someone swapped. So be very, very careful. Immediately you swap, okay, you know it's a trig ratio. So the ratio is very important. The numerator, the denominator, you cannot swap. So theta will be equal to tan inverse of this. Don't approximate. Okay, someone can choose to approximate this before finding the tan inverse. Remember, the more you approximate, the more you move away from the actual answer. So that will give us tan, okay, inverse of this. And if you use your calculator to find this, your calculator will give you this, okay, in 4dp. But you don't forget to indicate degrees, because theta here is an angle that is measured in degrees. Okay, if you ignore the degree here, then you will get a half, you won't get a1. Next time it will be a0. Then you come and draw your conclusion. Once you know theta, you know the bearing or the direction. So therefore, direction, or if you write bearing, only that I will entreat you to go for what is stated here. But that doesn't really matter. If you use bearing, they mean the same thing. We can use them interchangeably though. So it will be 90 degrees minus this value that you have in 4dp. Somebody can choose to approximate here to 1dp or to the nearest, did I say 1dp, nearest whole number. Then you come and subtract. It will be the same thing. Okay, because you know that the answer being required must be to the nearest degree, you can equally do so. So if you come and subtract, you will get this. But you know that here in bearing, angles are given in 3 digits. So you precede your whole number part because it's 2 digits, you precede it with 10. Then you approximate to what we said nearest degree. So this will give you plus 1, so 84 degrees. So 084. Without the 0, you won't get the A1. Please take note. It will be A half for now. Next time it will be A0. Remember, bearing angles are usually stated in 3 digits, especially the whole number part. So if you sum all that you have there, you are supposed to get 20 marks in all. Okay, so sum, give your score, whatever that you had over the total on top of your first page. On top of your first page, please take note. Your score over the total score. Don't indicate only your score. Then you capture your marked version and send it to me as well. Okay, so any questions before I bring the curtains down on this one? Any questions, my professors? Is the explanation okay? Okay, very good. On this note, I bring the curtains. Thank you very much for your time and attention. God bless us all.